Welcome, everyone, to techdaily.ai. We're the show that takes piles of important insights and research, and we basically boil them down into your shortcut to being genuinely well-informed. We pull out those key nuggets, maybe a few surprising facts, and try to keep it engaging. Today, we are diving deep into a really big shakeup in the artificial intelligence world, a major acquisition that points to some fundamental shifts in how AI models get deployed and, well, optimized. Before we dive in, though, I just want to mention that this deep dive is sponsored by Stonefly. They're your trusted solution provider and advisor for things like enterprise storage, backup disaster recovery, hyper-converged setups, VMware, Hyper-V, Proxmox clusters, AI servers, SA365 security appliances, public and private cloud. You can check them out at stonefly.com for more info.
All right, let's get into this. We're talking about a big acquisition, but maybe before we jump right into that news, let's set the scene a bit. For anyone listening who's trying to keep up with AI, which is moving incredibly fast, who exactly was CentML? What problem were they actually trying to solve?
Yeah, good place to start. CentML was really focused on one key thing, making machine learning way more efficient. Their core mission, basically, was optimizing those AI workloads, boosting the computational efficiency, and, really importantly, cutting the operational costs for customers. Their CEO, Gennady Pekimenko, had a great way of putting it. He said they were getting way more juice out of the available hardware for customers, specifically for, ML optimization. Think running AI faster, cheaper.
Getting more juice out of the hardware, I like that. And it sounds like they weren't just building like a mysterious black box either. I read their CTO, Sheng Wang, was a big believer in open source. He apparently said something like, the magic isn't just in the model, it's in how you run it. What did
Yeah.
that mean, and how did that whole open source thing give them an edge?
That's a really insightful quote, actually. It gets right to the core of what they did. What he meant was, look, the AI model itself, that's just part of it. How you actually deploy it, how you run it, how efficiently it uses the chips. That's where the huge performance gains and cost savings are found. And yeah, their open source approach was a massive advantage. Why? Because open compilers, they thrive when the whole community chips in. That community finds the weird stuff, those edge cases, the weird bottlenecks that a closed system might just paper over or miss entirely. This kind of collaboration just makes the tools much more robust, more flexible. Their key stuff included Hidet, that was their ML compiler, and CServe, their serving engine, which was built on VLLM, a really popular library for speeding up large language model serving.
Okay, so for someone actually using AI, deploying models, trying to max out their resources, what did the CentML platform actually do for them? What were the practical benefits?
Well, for the practitioner, it was kind of a dream setup, honestly. The CentML platform basically let developers pick pretty much any open model they liked, Llama, Mistral, DeepSeek, whatever, and then pointed at whatever hardware they had.
Yeah.
Could be Nvidia H100s, could be AMD's MI300Xs, even Google's TPUs. And the really cool part was CentML software stack that then just automatically handled all the tricky performance optimization and the deployment itself. Let me give you a concrete example they shared. They talked about optimizing an AWQ quantized DeepSeek R1 model. Now, AWQ quantized just means they cleverly shrunk the model size to make it super efficient without losing much intelligence. Using their own tool, Hexqute's like a special language inside their Hidet compiler. They got this, frankly, amazing 2x to 11x speed up right at the GPU kernel level, especially for something called the MOE layer, which is part of these big models. And then on top of that, at the sort of overall engine level, they get another 1.5x to 2x speed up using something called EGLE speculative decoding. It's like the AI guessing what's next to answer faster.
Wow, okay, 2x to 11x plus another boost. That's not trivial.
Not at all. Imagine a task taking an hour, suddenly finishing in, 5 or 10 minutes. That's the kind of leap we're talking about. And the platform automated everything around it, setting up the GPUs, the networking, scaling up or down automatically, even handling if something failed, making the complex stuff simple and incredibly fast.
That's huge on the tech side. But you mentioned costs earlier. Beyond just the raw speed and making deployment easier, CentML also had a strong argument about saving money and data privacy too, right? That's obviously massive for businesses.
Absolutely, yeah. They really pushed that angle. Their argument was that combining these open models with their, frankly, superior optimization systems wasn't just about going faster. It could deliver significantly better performance, but at dramatically lower costs. They did this internal test, comparing two identical chatbots. One ran on a competitor's serverless setup, the other on CentML's optimized stack. And the CentML one. It had better token throughput, lower latency, and resulted in a dramatically lower AWS bill. Think about the savings on cloud spend for companies running AI at scale.
A lower AWS bill always gets attention.
Always. And on privacy, which is just becoming more and more critical, they stressed offering dedicated deployments. So if you're handling sensitive information in your AI requests, you could have your own isolated setup. Knowing your private data isn't mingling in some shared environment, that's a huge deal for trust and compliance.
Right. So this wasn't just some lab experiment then. CentML was actually out there, making a real difference for companies using ML heavily. Where were they seeing traction?
Oh yeah, definitely not just theory. They had implementations across quite a few sectors.
Hmm.
Finance was a big one, optimizing algorithmic trading, faster computations, lower latency. That directly means potentially better trades, quicker decisions. Healthcare too, they were helping enhance diagnostic models, improving both the accuracy and just the operational speed, getting insights faster. And e-commerce, refining those recommendation systems everyone uses. Better recommendations mean happier customers, more sales. So yeah, really tangible impacts on efficiency and the bottom line.
Okay, so CentML was clearly doing some impressive work, making waves. Which brings us then to the big news, the acquisition. American chip giant Nvidia stepping in and acquiring CentML. What are the key details we know about this?
Right. The headline news is Nvidia acquired Toronto-based CentML. The actual amount wasn't disclosed, which is pretty common, but the timeline seems fairly clear. CentML's Canadian federal business registration was officially discontinued on June 6, 2025. And then an email went out to their customers saying operations would wrap up on July 17, 2025. And crucially, the leadership team, the CEO Gennady Pikimenko, COO Akbar Nurlibayev, and CTO Shang Wang, they've all moved into significant roles at Nvidia. Senior director, senior manager, manager-level roles in AI software and systems.
So not just buying the tech, but definitely the talent too.
Exactly. It looks very much like an acqui-hire. Reports indicate at least 15 engineers and a couple of interns also made the jump from CentML to Nvidia. They wanted the brains behind the operation.
Interesting. And, NVIDIA wasn't exactly a stranger here, were they? Didn't they already have a connection to CentML?
That's a really important piece of context, yeah. Nvidia had actually backed CentML previously. They participated in CentML's seed round back in October 2023. That was a sizable round, about $27 million US or $37 million Canadian. And that round, interestingly, was led by Gradient Ventures, which is Google's AI-focused fund. But NVIDIA was in there alongside other big names like Deloitte Ventures, Thomson Reuters Ventures, Radical Ventures. So yeah, NVIDIA knew them, had invested, clearly liked what they saw, and now decided to bring them all the way in-house.
Right, so they were already impressed. If we try and zoom out a bit, connect this to the bigger picture, what does this acquisition really tell us about where the AI industry is heading, especially from NVIDIA's perspective, given how dominant they are?
Well, I think the consensus is that this is a strong signal, as people are putting it, a signal that infrastructure, the part that runs the AI models after training, isn't just some secondary layer anymore. It clearly shows NVIDIA is making a strategic push to own both the hardware, their GPUs obviously, and the critical software layer that controls how efficiently AI inference runs on that hardware. Remember CentML's focus, it was that within model optimization, making single models run faster and cheaper using clever tricks like batching, quantization, kernel fusion. So NVIDIA is not just selling the pickaxes anymore. They want to control the whole gold mine operation, ensure you get the absolute maximum performance from their chips. It's a big vertical integration move.
Vertical integration makes sense. And it looks like this isn't just an NVIDIA thing. Their competitors are also looking north, specifically to Canada, for similar AI talent and efficiency gains.
That's right. It's definitely a trend. NVIDIA's biggest competitor, AMD Advanced Micro Devices. They also recently, just earlier in June 2025, acqui-hired the team from another Canadian AI chip company, Untethered AI. Untethered was developing its own AI inference chips, and their whole pitch was being faster and more energy efficient. So you see both giants recognizing that optimizing inference is absolutely critical, and they're snapping up specialized Canadian talent to help them win that race.
Which, of course, raises that question for the Canadian tech scene itself. These kinds of acquisitions, on one hand, it's great validation of the talent, but it also sparks a different conversation up there, doesn't it? It's kind of bittersweet.
It absolutely is. You hit the nail on the head. This move, and the AMD one, happened right around the time of Toronto Tech Week's homecoming event. And at that event, you had leaders from major Canadian tech companies, Shopify, Cohere, Wealthsimple, basically making public pleas for Canadian entrepreneurs to try and stay in Canada, to resist these big acquisition offers from foreign companies. Aidan Gomez, the CEO of Cohere, which is a major AI player itself, apparently just said flat out, you need to start saying no. So there's this undercurrent, this tension between the validation and excitement of these deals and a real desire within Canada to build and keep their own anchor tech companies, especially in a field as important as AI.
Yeah, a classic dilemma for successful tech ecosystems. Okay, so stepping back from the specific deal again, this whole thing highlights the just growing importance of AI inference. For our listener, maybe just quickly, why is inference becoming such a focal point compared to, say, AI training?
It's a great question because training gets a lot of headlines, right? Training is where you teach the AI model, feeding it vast amounts of data. It's incredibly resource intensive. But inference is when you actually use that trained model in the real world to make predictions, classify things, generate text, whatever the application is. And while training is huge, some experts predict the inference market could eventually be like 100 times bigger than the training market.
100 times.
Yeah. Think about it.
Yeah.
You train a model maybe once or periodically, but you might run inference on it millions or billions of times. Every time you use a voice assistant, get an online recommendation, see translated text, it's inference happening. So CentML's whole focus on making inference faster and cheaper, it directly targets this absolutely enormous and still rapidly growing demand for actually deploying AI in useful ways across every industry imaginable. It's where the rubber meets the road for AI value.
Got it. And CentML's approach, you mentioned the open source part, the optimization. It feels like it ties into this broader trend we've touched on before, decentralized machine learning, moving away from everything happening in one central place. What are the main reasons people are pushing for this decentralized approach?
There are several really compelling drivers for decentralized machine learning, or DML. First, and maybe the biggest one today, is preserving data privacy. With DML, the raw data can stay local, like on your phone or within a specific hospital's network. It doesn't have to be pooled centrally. This massively reduces the risks of big data breaches, misuse, unauthorized access. It's almost essential now for sectors like healthcare and finance where privacy rules are super strict.
Okay, privacy is huge. What else?
Second is overcoming scalability bottlenecks. Traditional centralized ML can really struggle as datasets just get astronomically large. DML, by spreading the computing and storage out across a whole network of devices, can scale much more gracefully. It lets AI learn from truly massive amounts of distributed data. Third, there's the potential for addressing bias and promoting fairness. Central datasets can sometimes bake in or even amplify existing societal biases. DML, by potentially drawing data from more diverse, dispersed sources, could help mitigate some of that bias and create more representative models, though that's still an active area of research.
Right, more diverse data potentially leading to fairer outcomes.
Potentially, yeah. And fourth, it enables computation in resource-constrained environments. Think smartwatches, sensors, devices with limited storage, or spotty internet. DML techniques allow some level of machine learning to happen right on those devices, which is key for the Internet of Things, edge computing, that sort of thing. Finally, it really fosters collaboration with privacy. Techniques like federated learning let, say, multiple hospitals train a shared medical AI model using their combined data, but without ever actually sharing the sensitive patient records directly. That's revolutionary.
Okay, lots of upsides, but decentralization can't be all smooth sailing. It sounds complex. What are the main hurdles or challenges people face when they try to distribute machine learning like this?
You're absolutely right. It definitely introduces new challenges. A big one is communication overhead. You've got model updates or parameters constantly being sent back and forth between potentially many devices. If you have low bandwidth or unreliable connections, that can become a serious bottleneck. Then there's heterogeneity. The devices involved might have vastly different computing power, different amounts of data, and crucially, the data itself might be very different, what researchers call non-IID, not identically and independently distributed. This variability can really complicate training and affect the final model's performance. And of course, there are significant security concerns. How do you protect this distributed system? Things like model poisoning, where someone maliciously injects bad data or bad updates to corrupt the model, become a real risk. Or other kinds of adversarial attacks trying to exploit the distributed nature of the system.
Security seems paramount, especially when you decentralize. And given CentML's focus on privacy and dedicated deployments, and now Nvidia potentially controlling more of the stack, It brings us back to zero trust security. We've talked about this idea before: never trust, always verify. How does that framework fit into protecting these complex distributed AI systems?
It's becoming absolutely critical. The zero trust model is increasingly seen as the way forward for securing ML systems, especially these decentralized ones. It flips the old trust but verify idea on its head.
So how does it work in practice for ML?
Well, several key principles apply. First, rigorous authentication. Every single thing involved, devices, users, software components, needs to be strongly authenticated and continuously verified. Location doesn't grant trust. Second, granular data access controls. You restrict data access to the absolute bare minimum needed for a task. Techniques like strong encryption, strict access control lists, maybe even differential privacy to anonymize data applied right at the source. Third, continuous monitoring and validation. You need real-time visibility into everything happening, data flowing in, model updates being shared, communication patterns. This helps detect anomalies quickly, like maybe a poisoning attempt or a data leak. Fourth is segmentation and isolation. You break the network into smaller, isolated zones. If one part gets compromised, the damage is contained. It can't easily spread everywhere, like putting potential problems in a smaller sandbox.
Containing the blast radius, basically.
Exactly. Fifth, the principle of least privilege access. Users, devices, services only get the absolute minimum permissions needed to do their specific job. If their credentials get stolen, the attacker has very limited access. And finally, underpinning all of this is strong encryption. Data needs to be encrypted everywhere when it's moving between devices in transit and when it's stored at rest, including the models themselves and any updates. Applying all these zero trust principles together is how you build trust and maintain integrity in these complex distributed ML environments.
Okay, that makes a lot of sense. So wrapping this all up then, as we finish this deep dive, it feels pretty clear that Nvidia buying CentML isn't just, some everyday corporate merger. It feels like a really profound statement about where AI is going in terms of efficiency, cost, and just its fundamental architecture.
I think that's exactly right. This acquisition really highlights NVIDIA's strategic push for deeper vertical integration in the AI stack. They're focusing hard on optimizing that crucial inference stage. By bringing CentML's know-how, their open-source chops, their focus on efficiency in-house, NVIDIA aims to solidify its dominance, and it also just underlines how important these decentralized approaches are becoming for privacy, for scale, for fairness, as machine learning continues to evolve and spread into, well, pretty much everything.
So here's something to chew on as we finish. What really stands out to you, the listener, about this NVIDIA CentML move? Do you think NVIDIA bringing CentML's open source expertise under its wing will truly lead to better AI efficiency across all kinds of hardware? Or could it, maybe paradoxically, end up leading to even more centralized control by NVIDIA over the whole AI infrastructure landscape down the line? Definitely something to think about. Before we sign off, just one last reminder about our sponsor, Stonefly. If you're looking for solutions in enterprise storage, AI servers, backup and disaster recovery, hyper-converged infrastructure, or cloud solutions, Stonefly is a trusted provider and advisor. You can find out more at stonefly.com. And while you're there, check out their pretty impressive 100 terabyte immutable and air-gapped SSO NAS. It's available for just $8,995.